So thank you for joining us for this event. We start with the special speakers is Sneha. Sneha, hi. Do you want to introduce yourself?
Hey, thank you so much. Hi, everyone. And thank you all so much for being here today. I'm Sneha, and I'm currently studying in Amrita Vishwavidyapeetham at Bangalore, India, and I'm doing undergrad course in AI. So I'm really happy to be here today and take this session. So let's get started. I'll share my screen. Okay. So is my screen visible to everyone?
Yes, Sneha.
Yeah, okay. So hello, everyone. Once again, welcome to this session, and thank you all so much for joining here today. And let's all learn today all about big data, at least a theoretical approach to what big data is, right? So before we get formally started with what big data is, I want to ask you one question. If you think about that, we always text our friends, our relatives, our family members, we send so many messages in a day. If you think of a rough estimate as to how many messages are sent worldwide in a day, what do you think that number would be? Like how many messages worldwide, not just from you, but from everyone to everyone? How many messages do you think are transmitted on like WhatsApp or Instagram or Messenger almost every day? Maybe you can like give a rough approximate in the chat if you can. And if you have any answers here. Okay, 7 billion. That's a good amount. That's a good guess. All right. So let's move on. There are around 23 billion texts that are actually sent around every day. That is 270,000 texts sent per second. And this is inclusive of all the different apps you use for texting. There are around 23 billion. Imagine that number, right? And not just this, right? If you look at YouTube, around 5 billion videos are watched on YouTube every day. And Google gets around 8.5 billion searches. So why am I ranting about all these numbers to you? Well, that is to show you the actual ginormous amount of data that's present in our world today. We have so many messages, so much activity happening constantly on the internet, and each activity that's happening on the internet generates so much data. So let's take YouTube, for example, right? When you watch a video, let's say you like watching food videos, which I actually love watching food videos. You watch a recipe video, you get other 10 recommendations for recipe videos. Why? Because your data is analyzed, right? YouTube analyzes the data that you're using. It looks at the pattern of your previous watches, analyzes what you're currently doing, and that's how it's able to generate recommendations for you. So imagine if there are 5 billion videos that are watched on YouTube in just one day, how much data does YouTube have to analyze and give personal recommendations? And if there is so much data, how can it be handled? Are there any new technologies? And that's what we're going to talk about in today's presentation. So before all that, I threw around one word a lot, that was data. So let's learn about data. So what exactly is data? Data is something known as processed or formatted information. So any information you get in a processed format or something that's formatted, that is known as data. So you can think of these are some quantities, and on these quantities, what you can do is you can apply some sort of computer operations, and these are some quantities that can either be stored somewhere or can be transmitted somewhere through like electrical signals or in the form of packets or in various other forms. So these are just quantities which you can store somewhere, where you can perform operations and you can transmit this. So such quantities are known as data. So as you can see in this infographic here, data is basically different quantities. You have processed information, and you can also think of data as graphs, measurements, observations, facts, as well as numbers. So that's what data is, right? Now, data has a variety of types, and we'll mainly be listing down 3 types. That is important for us to understand big data. So data has 3 types, that is structured, semi-structured, and unstructured. So what is structured data? Structured data is one where you have that data and you can basically decompose it into tables, that is in the form of rows and columns. So this is known as relational data. And what we do is we usually use SQL to help you access this data, manipulate this data, extract information from here. So that is known as structured data. As the name suggests, this data can be conformed to one sort of structure. So there is like rows and columns. Semi-structured data is one, it's data that's not completely unorganized, neither is it completely structured. So it has some form of organization, but it's not that well structured as structured data. And for this, you can think of XML files. So you have XML files. They're not completely unordered, but they're not as structured as rows and columns, right? So that's semi-structured. Then you have unstructured data. So unstructured data has really no organization or no format at all. And if you want to access and manipulate such data, it actually becomes quite difficult. So it's the easiest with the structured data to access and manipulate and extract information. And it's the toughest with unstructured data. So you can think of Word files, as pictures, videos, all these are unstructured data because you can't, why are they called unstructured data? Because you can't easily access the information and you can't easily manipulate the information that's present in this data because they don't follow any particular format, right? So that's the three different types of data. Now we've understood what data is. Let's understand what big data is. So as the name suggests, big data is basically data that has a large volume. And this large volume of data actually continuously grows. So it's data that is voluminous in sizes, has an enormous size. That's what big data is. It's just data, but with a larger size. And usually what happens is since data has such large size, it's difficult to store this data and get insights from this data. So, but if you are able to do that properly, that is, if your business has a large amount of data and you're able to handle this large amount of data, you're able to store this large amount of data and you're able to analyze and get insights from this large amount of data, then you can tackle many, many business problems. And we'll talk more about these examples later on in the slides. So that's what big data is. As the name suggests, just think of big data as data that's large in size. That's all. Okay, so now we know that data science and AI sort of form an ecosystem of their own, right? You have artificial intelligence, a subset of that is machine learning, and a subset of that is deep learning. And then you have data science, which uses all of these algorithms, plus also has a few mathematics and things of its own. But then where does big data fall in this whole spectrum, right? Where does big data fall? How does big data fall here? If you think about it, big data is basically analyzing large amounts of data. So maybe can anyone try to venture a guess as to where will big data fall over here? You can just think of it like, you know, you have artificial intelligence, then you have machine learning, deep learning, and then you have a Venn diagram of data science overlapping it. Maybe think of any possible place where we can put big data over here. All right. So basically, big data falls right in the middle. Okay, actually big data is not such a small circle, it's a huge circle because it has properties of its own that's different from data science and deep learning. But mainly you can think of it as an intersection between data science as well as artificial intelligence, machine learning, and deep learning. Why do we call this as an intersection between these two spectrums of AI? Because big data, as the name suggests, it's dealing with large amounts of data. So you store and process more data than you do with just general data science methods. So that's why it follows the data part of data science, but also it uses a few methods. There are a few methods in artificial intelligence, machine learning, and deep learning, which is used in big data to help you analyze and basically derive insights from that particular data that's given. That's why it's considered like an intersection between these two. And it has a few properties of its own. That is, it needs to understand how you can collect data from, in big data, you need to understand how to collect data from different sources and how to basically store that data and manage the data. So that's what's different. That's what makes big data a little different from normal data science as well as artificial intelligence. But otherwise, it also deals with, cleaning the data and doing a few data science processes. But also you need a few algorithms to help you ultimately analyze what you need or what is your ultimate outcome from the data that you collected. So that's where big data basically falls into the ecospace of AI and data science. So now, as with any technology, it's always nice to know where it originated. So for you to understand why you need to use it, right? So before 2005, in fact, very rarely was the term big data mentioned. Maybe once here or there in the 80s or the 90s, there would have been one research paper where they would have mentioned the term big data. But otherwise, nobody really saw a huge need for it. But in 2005, when the usage of YouTube and Facebook basically skyrocketed, that is when people found it so difficult to manage all that data, to manage all those different types of data that they're getting in their websites. That is when they started using big data mainstream. So there was a technology known as Hadoop, which they used. Basically, Hadoop is very popular big data technology used to store data and help you manage the data. So that's when Facebook and YouTube were facing all these issues, that's when they came up with whole concept of big data, and they came up with the whole concept of Hadoop and NoSQL basically to help you store this large amounts of data and give you a better mechanism and a better framework to analyze all this large data. So because the usage of all these websites went exponential, that's when people realized that, okay, this is needed. Like we need some sort of technology or some sort of framework to help us handle this. And that's how big data came into the mainstream. And that's where Hadoop, which is a very popular big data technology, was introduced. So that's about the history. Now let's learn something very important, that is the applications of big data. So now we learned about what big data is and why it came into place. Now, right now in our current situation, where is big data used? How is it helping us in our everyday lives? Well, there are a variety of domains, a variety of sectors where big data is used. Let's start with, let's say, the financial and the banking sector. So why do we use big data in the financial and banking sector? Well, a customer usually does a lot of transactions. They make a lot of transactions when they're dealing with the bank. And what big data does, it helps you analyze these transactions. When you analyze these transactions, you can see how a customer is dealing with their finances and what type of financial projects are they taking into. What are they investing in? Are they investing smartly? And when you do all of this, you can recommend, different things to the customer, saying, okay, now that you invested in this project, you can maybe invest in something else. You can look at how they're spending and give them, help you analyze better on customers spending or other behavior pattern. So that's what's used in the financial and banking sector. And also it's helpful in detecting frauds, because in the financial and banking sector, what usually happens is there are a lot of frauds, a lot of scams that happen. So big data, it helps you collect different and a large amount of data. And when you have large amount of data, you get better insights. So when you get better insights, you can easily and quickly detect frauds. Now, tracking customer behavior, like I mentioned in the banking sector, you look at the consumers, basically their spending techniques, and then you're able to recommend things to them. Similarly, if you look at our previous example of YouTube, once you watch a YouTube video, you get a lot of other recommendations. So that also is because of huge data. You take huge data. With that huge data for a particular customer, you're able to analyze their past behavior. And once you're able to analyze their past behavior, you can further see, okay, this was how you fared before. Now, like these are the few recommendations I have for you. Similarly, you can do that for Netflix. That's what Netflix does, right? Or you can take it for e-commerce sites such as Amazon. You buy a product, and that's the data. That's the data. You buy a product, and then the Apple itself recommends saying, okay, since you bought this, maybe you can buy so and so. So that's all about tracking customer behavior. The more the data you have for this particular scenario, the better insights you get. Then you have something called air traffic system. So for air traffic system, what happens is that there are a few sensors in these airplanes where what these sensors do is they help you detect outside the aircraft, what is the environment like, so what's the temperature like, what's the humidity like, what's the rainfall situation like outside the actual aircraft. And because these sensors are able to detect all this information, and this is a large amount of information, once it's dealt with properly, what can happen is that inside the aircraft, the temperatures or the environment set inside the aircraft can be done well to match its external environment. So that is one use case. Another is that there are a few IoT sensors that are always present inside the aircraft. And what these sensors do basically is they help you check how well you're operating that aircraft, what type of operation measures you're taking with the aircraft. And based on how you're treating your aircraft or how well you're managing your aircraft, it's able to predict till when can you use this aircraft. Because when it comes to things like aircraft, right, it's very important that you always have them in tip-top condition so that you can be safe and careful, right? So when the condition of that particular aircraft starts degrading, you usually want to replace it. So this sensor helps you detect, these are IoT sensors, and they help you detect the operational efficiency of that aircraft. They help you detect till when can you use that aircraft, like how is the make and manage of the aircraft, and because of its make and model, till when can you use it. So it has two different use cases here. And again, when you're using sensors gather a large amount of data, and for that you use big data to help you store it as well as analyze it. Similarly, healthcare, if you look at, you have patients records that are digitized this time, and you have we just had a pandemic outbreak. So now a lot of systems are gathering data to predict the next pandemic outbreak so we can be careful and safe. And there are a lot of preventable diseases. There are a lot of diseases that are small and preventable. So for those, they just have a few factors. So it's important enough to collect the data for those few factors and help patients, prevent that data. So for all of this, we use big data in healthcare. Then education. So if you look at education, right? Someone is studying college or a school. So what we can do is we can look at a user and evaluate the user completely. So when we evaluate the user completely, we gather data from that user. What we can see is what is this user like? What is this user not like? How is this user performing basically, or how is the student performing in his or her exams, and how well are they doing in so and so subjects? And based on all this, what they like, what they don't like, and how they're faring in different subjects, we can help chart out career paths for these students. We can help chart out, like, what would be the best possible position for you to be in, what would be your best possible ambition, and things like that. And this will really help you as a student to build your future and start planning from a very young age. So while this is not that much in use right now, there are a few universities like University of Florida, which takes the help of IBM's big data systems. And using IBM's big data system, they actually analyze all of this data for students, and they help and provide better career counseling for all of these students. So that's with respect to education. Now, agriculture. Now, agriculture is becoming smart agriculture nowadays, because there are so many systems that help you decide when to plant, when not to plant, how much irrigation should be there, what type of irrigation should be there, what are the type of pesticides that you need to use, and all this is data. So when all this data can be consolidated into just one place, and you can provide the farmer with a particular immediate analysis of all of this data, that would be really great and would be helpful for the farmer to plant their crops in the best possible condition. So that's what it's used in agriculture. If you collect all of this data consolidated, and as an example, there is this particular agriculture company that basically uses big data to detect where there are weeds in that particular farming land. So it uses big data and actually detects where there are weeds. So it's easier for you to actually pull those weeds, and you have better accuracy when you're using such a model, right? Because you have a large field. So imagine you will have to walk all by yourself and then detect weeds. Rather, if you have a model that says, okay, here there are weeds and there are weeds, then you have to just go here and there, and that helps you do all of your work faster and helps you improve your efficiency, right? So that's with respect to agriculture. Now, manufacturing. When you are manufacturing a product, you have like a design phase, a production cycle, and all of that, right? But what big data does is that, again, it takes all of these phases, collects data from all of these phases, consolidates all that data, and then helps you in better analyzing, or gives you better insights into how you can faster do this entire process. So if you take the example of Rolls-Royce, the company Rolls-Royce, what they do is in their design phase in itself, they do something where because of this big data, they're able to look at where they've made errors in the design phase. Where if this was put into production, this could cause a problem in this design itself. So because they're catching up these errors in design itself, they're one, reducing costs a lot, and two, they're increasing their efficiency, and it's all thanks to big data. So this was a lot of fields, and I'm sure it was a lot of information for all of you as well. So if you have any questions, do feel free to put them in the Q&A box. But yes, these are the various, these are just a few out of the many other areas where big data is actually used. So that's how big data is used in today's day and age. So now I'll be going and talking about some concepts that are involved in big data. So if any of you have any doubts so far, or anything you want me to repeat again, I'll maybe wait for a second or so, for a minute or so, and then I'll proceed ahead. So if you have any doubts, or if you have anything that you want to clarify, or anything you want me to repeat again, do let me. right? Okay. All right, then I will be moving on. So now what we'll be doing is we'll be talking about a few concepts that are involved in big data, right? So let me get started. Nice. Yes. So first we have a very important concept, and this is known as the 5 V's of big data. And why is this so important? Because these 5 V's are what define the entire characteristic of a big data. How will you know if something is big data or just data? That is by using these 5 V's. So starting with volume, which is, I think, the most important factor that defines or characterizes big data. So we know that big data is basically data that's voluminous or has a large volume because it's been taken from a umpteen number of sources. There are many sources where you take all this data from, and this data is large. It has a huge volume, and that's why it's known as big data. So usually, the more the volume of your data, if you're able to better analyze that data, then you can gain better insights. And there's a particular volume threshold, to take it from data to big data. So once it crosses that volume threshold, you actually start using all different types of big data technologies like Hadoop and things. So volume is a very defining characteristic. We are able to understand how enormous the data is, how using this enormous data, is it big data or not, and what type of technologies to use. And the more enormous the data is, the better insights you get if you analyze it well. So that's about volume, basically the amount of data or the size of data. Second V is variety. Now, variety, like I mentioned, data had 3 types, right? I mentioned in this previous slide, where data is of 3 types. You have structured data, unstructured, semi-structured data, as well as unstructured data. So, and I mentioned examples as well, like SQL tables, and then you have photos, images, Word files, documents, and you have XML files and things like that. So variety of data basically depends on the multitude of sources you're getting this data from. So you are very lucky in today's day and age if you're going to be collecting data from a single source. That is the easiest way, agree. But that never happens because data for a particular business idea, right? Data could be available anywhere, and you can get this data from anywhere. And because you're getting this data from anywhere, it could be of any format. You may get some of the data that's from an SQL table, so it's structured, and some of the data may be in the form of photos, videos, so that may be unstructured. So you don't know where you're getting this data from. And what you will actually have to do is get these data from all of these sources, consolidate them, and put them into one format so you can analyze them. So variety is very important in big data. Variety is another thing that is pretty important in big data, and variety is something you will always find in big data, because when you're collecting data, especially of such a large volume, you will not be able to rely on just one source. You will definitely have you'll definitely be in the position where you're using it from a variety of sources. So that's variety. You have data that's of different formats, that's structured, semi-structured, as well as unstructured. So we finished volume, the size of data, variety, the types of data. Then let's go to velocity, which is the speed at which data is generated. Now, data, so we sometimes have static data where you've just taken that data and that data does not change. But let's say you're doing something known as weather prediction. Weather prediction, you don't just do it for one day. You do it for many days continuously. That means that if you're doing it for today, you need data that's latest. If you're doing it for tomorrow or a week later, you can't use today's data. You need the data of that week. That means data is continuously being generated for this. And you need to continuously be able to maximize your resources and be able to hold this data, consolidate this data, and analyze this data. And people now usually use cloud technologies for all this, because cloud technologies provide easy access or easy storage of resources, right? So you need to be able to make your cloud technology or make whatever resource you're using adaptable in such a way that it can handle the speed at which data is coming, and you can store it and then consolidate it and analyze it. So that is velocity, which is basically the speed at which you're continuously getting data for whichever big data application you're using. Then you have something known as veracity. Now, veracity is basically how much can you trust your data. So like we mentioned, this is large amounts of data. You're not simply getting it from one source. You're getting it from a variety of sources, structured, unstructured, and semi-structured. And this data is something that keeps on coming. So sometimes you may have static data, but in most real-time big data applications, like what we discussed in this slide, right? In most of these applications, you have data that is continuously pouring in at a great speed. When you have all of this, right, how do you know which data can be trusted? Like, how do you know what is the data that can be used for the business case and what is the data that cannot be used for the business case? So you must always decide that before you go ahead and use that data for further processing. You need to be able to understand what part of this data makes it accurate, and where are there inconsistencies in this data, right? So that's a very defining factor for you to actually use, for you to put on the data before you actually analyze it. So you need to be able to understand how much can you trust this data, where could there possibly be inconsistencies, where could the redundancies occur. You need to find out all of these factors before you actually put it for production. So that is veracity of data. How can you understand your data? How can you trust your data? How much can you trust your data, right? So that is veracity. Then you have value. So what is the value of the data being? That's literally what is the value of the data being collected. That is, let's say now you have large amount of data from different sources. The data keeps coming on in, but then you realize that you're not able to put it into a proper form, and you're not able to get value from it to solve your business problem. Then what is the point? What was the point of collecting all of this data? What is the point of analyzing all this data if it's not able to solve your particular business problem? That means this data has no value. You need to always find valuable data. You need data that will help you actually analyze and access and solve the business problem you currently have at hand. So that is about the value of data. So you have all of these. So all of this now forms the big five. So you need volume. There is the enormosity of the data. That's very important in big data. You need variety. So you have variety from different sources. You can't always, you may not always get your data from one source, and neither can you just simply rely on one source, because that will not give you the most accurate and the most versatile data. Then your velocity. In most real-time applications, data keeps coming on in and in and in at a very fast pace. That's velocity. Then you have veracity. That is, you need to be able to understand in all this gigantic or ginormous data that you have, which part of the data can you actually trust? How much data can you actually trust? Where are the inconsistencies? Where are the redundancies? And finally, you need to be able to make sure that the data that you're getting is valuable to your business problem. The data that you're getting can solve what you want it to solve and can be analyzed and consolidated in such a way that you're able to gain good insights. So these are actually the 5 V's that define the characteristics of big data. Again, it's a very important concept, and this is basically the foundation of big data. So anywhere, any of these have a doubt in, or any of these that you want me to repeat again, please don't hesitate in asking that. Put it in the Q&A box, and I will definitely come back to that towards the end of the session. So yes, don't hesitate and ask me to repeat as well. I'll be more than happy to do that. All right. So that was about the characteristics of big data. That's what we just spoke about. Now let's talk about the big data lifecycle, or how does big data exactly work? Now we understood like what defines a big data, or what are the characteristics we must look for in big data. But how does big data work, right? So here are the 4. So this is one of the, consolidated life cycle. A life cycle could be deeper than this. It could have more steps. But what I have done is I found the most comprehensive life cycle, and I thought I'd explain that to you, right? So for big data lifecycle, we have 4 steps. First, collect it. We have to, like I mentioned, we have different sources where we get data. So what we need to do is we need to use all of these different sources and actually collect that data. That's the step number 1. Collect data from different sources, such as personal drives or shared drives or websites or from data warehouses and things like that. So that is the step number 1. Step number 2 is that now we have all of this data. What do we do with it? We cannot just keep it elsewhere. We need to store that data, because when we have to analyze it, we need to be able to take it from somewhere else, right? We need to store it properly. So consolidating all of this data is basically what storing is. And what storing also helps you do is it helps you find redundancies in that data and helps you remove those redundancies. So if you use big data technologies such as Hadoop for storing, then that will help you, that will give you like a way to help you reduce the redundancy of data. So when you reduce redundancy of data, the data becomes smaller and easier for you to manage. If you have very redundant data, then analyzing all that will just be a waste of time for you. So that is storing the data. Then comes analyzing the data. So here is where you will be using different visualization technologies such as Tableau, or you'll be using artificial intelligence and machine learning technologies to basically analyze the data and find insights from the data. Like, okay, what from this data, what can I use? And how are you going to be able to solve your business problem from this data that you just collected? That's analyzing. Then governance is actually very important and often overlooked. Governance is something where you collected all your data, you've stored it, you've analyzed it, you've gotten some results. but you need to keep that results going. You need to make those results available and usable to everyone whenever they need it. So that is the governance of data. You need to be able to basically help people or help users access that data and use it whenever they require. So these are the 4 basic steps of the big data lifecycle. You have collecting data from a variety of sources. You have to store that data, and you should use storing technologies that help you remove redundancy. You need to analyze the data using any technology you have, or you can use machine learning and AI technologies. And then you need to have data governance, big data governance, which is making those results and making that usable and available to the users whenever they require for their business problems as well. So these are the 4 basic steps of the big data lifecycle. All right. So now let's talk about advantages of big data. So like as with any technology, they always have the good side and the bad side. They'll have some advantages as well as some disadvantages. So first, let's focus on what are these advantages of big data, right? Now, big data helps in better decision making. How? How does it help you in better decision making? Well, like I said, big data is large and an enormous amount of data. And as I kept mentioning before, if you're able to analyze and use the data well, then you're getting better insights. And whichever company you go to, the better the insights you have, the more comprehensive way you can make a result out of it, the more comprehensive way that you can actually see what actionable outcome can you get from it. So that's how it helps you make better decisions. So whichever company you're a part of, the more data you analyze and the better way that you analyze this data, you're able to actually see how and in what steps you can take to progress further. So that is better decision making. Again, it depends on any field. So it could be education field, it could be healthcare. So in healthcare as well, if you, like, suppose you're building a model to predict the easily detectable diseases or predict preventable diseases, then the more the data you have, the better the insights you have, as to how you can predict this and how you can gain an outcome out of this. So with any field, better decision making is vital. You need to make good decisions and you need to make the best possible decision at that particular place. And that can be done using big data. Then you have cost optimization. So cost optimization is because when you use big data technologies to store and analyze your data, that actually takes lesser cost than if you do it on your own, or if you use basic you use normal data handling technologies to do it. If you use normal data handling technologies to do it, what will happen is that your data is not very safe. When I mean by not very safe, it's that your data could be lost at any point, because the normal data handling technologies do not have the capability to handle data of such a big volume. So when you do use big data technologies, at that case, you're able to handle data at such a big volume, you're able to store it. And that helps you reduce costs as a company, and you can put that cost to better use for something else rather than the redundant or the menial task of storing the data and managing this data. So definitely it helps you in cost optimization. Better fraud detection. So I spoke about this briefly when we were talking about the banking and the finance sector. So I'll touch upon it again, where when you think not just the banking and the finance sector, any of the sectors or any domain you take, when you have such large amount of data for your business, you will have also some data where fraudulent activities have happened. So when you have this data where fraudulent activities have happened, what you can do is you can train your AI or your ML model to detect these frauds. And the larger the data you have for fraudulent activities, the better your AI model will be. And the better your AI model will be, the faster you're able to detect frauds. So, some credit card companies, when there has been a fraudulent transaction or there's some sort of fishy behavior happening to your card, the credit card company will be informing it to you way before the user notices it themselves. And that's the power of big data. That's the power of having so much data and being able to analyze it better and being able to make better decisions. So when you have more data, you can detect these frauds. Frauds are basically anomalies. Why do I call them anomalies? Because the fraudulent transactions are much, much lesser than the normal transaction. We make more normal transactions than we do fraudulent transactions. Whereas fraudulent transactions are something that's not normal, that's an anomaly. And with more data, it's easier for you to detect these anomalies. All right, so that is about, so we had better decision making, we have cost optimization, we have better fraud detection, we can improve efficiency. Now, because of all of this, we have better decision making. We have one good platform, basically store and access your data. And because of all of this, the efficiency of doing things is improved. There's more productivity for that particular big data scientist, because you have found ways to make your data and analyze your data easier. And what this does is, because you're improving efficiency, because you have better methods to do this data storing and analyzing, this helps the big data scientists to focus more on innovation. When they focus more on innovation, they create better products. And when they create better products, they're helping serve their customers better and get better feedbacks and better response from their customers, if I would say. So when you have something else to do your menial tasks of storing and analyzing, and you have technologies that are well versed to do that for you, and you can make better decisions as a reason of it, and you can optimize your cost better, your mind wanders towards innovation. You can make better products for your customers. You can serve your customers much better than you did before because of all of these technologies. And you're still making better decisions because you have more data than you ever did before, right? So that's how you're able to improve efficiency. And finally, customer acquisition and retention. That again is similar to what we do is when a customer uses a product for a particular company, let's say Amazon or Netflix or things like that, these big data technologies are able to actually analyze the customer's consumer behavior. And from this consumer behavior, able to see and personalize the experience for that particular consumer. What would they use, and personally for them, what would they like, what can be recommended for them. Like I mentioned, Amazon, you can recommend a particular product for a user based on their previous purchases. And for Netflix, you can recommend particular movies or particular TV shows for users based on what they watched before. And that's all about, and when you do that, so when someone's when a website is saying that, okay, now that you watch this, also watch this, you will continue using Netflix, right? You will continue being on that product, you will continue using their services. And similarly, when Amazon mentions, since you bought this, you can also buy this, or giving you such personalized recommendations, you'll feel like using that app more, because you get all your choices personally. You get things that are just for yourself, and that will help you retain your customers better. So that'll help any business retain their customers better. And that's what big data helps in. Because of all the large data, it helps you track every consumer's behavior well. And that gives you a large data. And because it's big data and it's voluminous, and big data can handle all of this, it helps you acquire more customers and helps you retain those customers, because you're making personal choices just for them. So these are just a few advantages of big data. Any company can make better decisions. There's always a cost optimization. Fraud detection happens at a faster rate. There's more efficiency, and customer acquisition and retention happens at a better rate. So those are the advantages of big data. Now let's look at some pitfalls or some challenges that big data is facing. So it's still difficult to keep up with the exponential volume of data. So while we do have these technologies, they're able to hold some amount of data. Now data is increasing at a more rapid pace, especially now that we have the pandemic and everything was on the internet. Everything relied on using internet services. Data has been at the highest scale it can, like higher than ever before. So because it doesn't stop there, it's not stagnant, it just keeps growing. It sometimes becomes a little challenge for even big data technologies to handle this continuous exponential growth of data. Then privacy and security. So what most companies tend to do is that they collect this big data, they store it, they immediately think about ways to analyze it and get results, but they forget one tiny aspect, which is the securing this data. And what they do is, okay, securing is fine, we can just do it in the end. That's what most companies tend to do. And that's why there are sometimes you see information is leaked out to the public, or sensitive information is leaked out to the public because of this. So security is something that should be integrated into in fact, it should be integrated into like the big data lifecycle in itself. Security is a very important step that needs to be taken, but is usually overlooked or is usually done towards the end, or kept as a last option for a lot of companies, which is what leads to all of these security scandals. So that's something that's a challenge. And why do most companies keep it towards the end? Because there is such a large amount of data, and for such a large amount of data, it becomes difficult for them to actually find and sit and secure all of this data, which is why they think it's more important to analyze and get outcomes from this data rather than spend the time securing this data, which is not the case, which is not true, which is not what should be done. So privacy and security also falls under one of the challenges, because it becomes quite difficult to actually secure all this data. And because it's so difficult, companies tend to put it off till the end. Then excessive time taken to clean the data. Now, this is the case for big data as well as data science. So we know that data scientists spend almost 50 to 80% of their time actually cleaning that given data, finding out if there are redundancies, finding out if there are inconsistencies, removing that, and making a useful shell of what can be used to actually analyze and get your outcome. So those are some challenges, like that is a very, very huge challenge of big data as well as data science, the time taken to clean the data. Then we don't have a lot of experts who are you don't have a lot of people who are experts on the subject matter. There are not a lot of people who know actually what big data is, how is it different from normal data, and people who are who actually know where big data is differing and how do we need to handle this data different compared to normal data. And because there are no there's a lack of talent, there's a lack of usage of these big data as well, because there's a lack of talent or lack of know-how of how to use it. Then finally, there's a difficulty in sharing and accessing the data. Since your data is so large and so vast and so enormous, you store it in one place, but it becomes, if you want to share it with someone else, or if you want to easily access what is there, it becomes quite difficult because first of all, the data is so large. Secondly, the data is, has so much variety from different sources. So it becomes difficult if you want to share this data between two people, or if you yourself want to access some data, it becomes quite a tedious task to do all of these things. So these are some very, very prominent challenges of big data, because it's still growing, it's exponentially growing, and even big data technologies are finding it difficult to keep up. Privacy and security is very difficult. I mean, it's very difficult to secure such a large amount of data, which is why companies just put it off till the end. Then because the data is so large, it takes a lot of time to clean this data, and around 50 to 80% of the time of data scientists goes towards cleaning the data. Then you have like a lack of talent or a lack of experts who know the technology in depth, and because of this there's a lack of usage also of this data. And then when you have the data already stored and secured in some place, it's very difficult to share such a large amount of data or access such a large amount of data. So these are some challenges which people are still looking for ways to overcome in big data. So yes. And finally, I'll be ending today's talk with what are big data technologies. So I kept talking about different big data technologies that can be used. These are some big data technologies. So we have Kafka and Spark, where you can use Kafka and Spark if you basically want to gain some insights or analyze your data. Similarly, you can use R if you want to gain insights or analyze. And you can use MongoDB and SQL again if you want to store this data and access and manipulate this data. You can use Elasticsearch, and you can use Elasticsearch to basically perform data mining. Again, Cassandra also can be used with Kafka and Spark to analyze your data. And you can use Tableau if you want to visualize your data. So these are just a few out of the many different technologies that are there. Very popular one that's used in big data is actually Hadoop. So yeah, so these are the enormous technologies or the different types of technologies that are there that can help you store the data, that can help you access the data, that can help you manipulate the data, that can help you analyze the given data, and that can help you visualize data, because it's easier for you to actually gain insights from the data when you visualize it. So these are all the different big data technologies that are used. And before I end, I just want to say, if SQL is again a very prominent big data technology, and if you want to learn more about SQL and you want to know how to use SQL, and you want to prepare for SQL for maybe data science interviews or things like that, then you should definitely check out our SQL series, which is coming out this January. So do keep a watch for that. Join our Slack channels and join our track events channel, where you get updates onto when these events are going to actually start. So that will be a really good series, and people are putting in a lot of work to find content for that. So definitely do attend that, which is happening in January this year. So that brings me to the end of my talk. I'm sure we had a lot of things spoken about today. We spoke about what is big data, some history of big data, where does it fall in AI and ML ecospace, and then what are the 5 V's, or what the main concept, the 5 V's of big data, what are some big data technologies, the life cycle of big data, and a few advantages and disadvantages. So I'm sure it might have been quite a bit of information for some people. And if there's anything, again, like I said, you want me to repeat or mention again, let me know. And yes, Victoria, if there are any questions for me, please do let me know. And if you have any questions, guys, please do put that on the Q&A box so that I can see it and we can answer the questions as well.
Yes, thank you, Sneha, for your amazing talk. Yes, we have a question. Someone asked, data is obviously vulnerable to leaks. Following this, wouldn't bigger amounts of data mean more vulnerability? How will you take extra precautions?
Precautions.
Um, Precautions.
Yes.
Okay.
So that's a really good question. And like I mentioned before, in one of the disadvantages is that yes, because data is not usually secured by companies, it does sometimes tend to leaks. But what happens in big data is that there is something known as fault tolerance. Let me explain what fault tolerance is, right? So let's say you're storing some amount of big data, like you have some important files. It's not just stored in one location, it's stored in 4 or 5 other locations. So that means that you have data available here and data available everywhere else also. So if your current data center fails, then you have many other data centers where you can actually gain this data from. So when you're talking about like data being available or data being usable, then you have this data that's stored in various other places and you can actually take this data from there. But with the security issue, that's still quite a challenge, and that's still something that's being worked on by big data technologies as well as data scientists. So yeah, I think I took 2 different approaches to your answer. So if you have any follow-up questions, do let me know.
Awesome. We don't have any other questions, but yes, if you have a question for this talk, you can ask in the Q&A box for that.
And if you have any other like things you want me to repeat, or something that that was a heavy concept that you want me to speak again, that'd be good. You can always ask me that. So maybe we'll just wait for another minute or so. And if there's nothing, I think, Mansi, we can end the session. Thank you all again so much for attending today and bearing with me through this 1 hour and listening to everything about big data. I hope in some way, at least, I've helped you spark a little bit of a passion, a little bit of an interest towards big data. And hopefully from here on, you can try learning more about big data, and we'd love to see all of your big data projects. So do join our Slack channels. And if you have any doubts in big data, or if you have like project ideas, or you're doing a project in big data and would like some help, definitely do ask us on our Slack channels, and we'd love to help you all out. So I'll just wait for another minute or so for any questions or anything, and then I think we can end the session.
Well, yes. Well, thank you so much, everyone, for joining this amazing talk, these sessions. So later we will going to send the recorder and the material. And yes, thank you so much, and see you soon.
Bye.